Hi, I'm Shashwat. I hope you're having a really great day. In the previous episode, we discussed Z-depth, deep pixel, position maps, and position pass. And we also saw how we can use position pass effectively. We also encountered some challenges relating to the position pass, as different 3D softwares and renderers have different coordinate systems to represent their channel data. For instance, in Blender, the x-axis, which is red, goes left to right, the y-axis, which is green, goes forward and backwards, and the z-axis, which is blue, go up and down. In contrast, in Fusion, the x-axis is left to right, the y-axis is up and down, and the z-axis goes forward and backward. This discrepancy leads to issues when exporting our normal and position paths from Blender. Today we'll address these issues, focusing not only on exporting from Blender but also from other 3D softwares that may face similar coordinate system problem in Fusion, Nuke or any other compositing software. So here we have a beauty pass and position pass. And what I have done is, I have created a short animation of about 50 frames that I'll play for you now. You can see it's a simple animation with a tracking and dolly movement. Now, if you remember in the previous episode, when we looked at the position pass, red represents the x-axis, green represents the y-axis, and blue represents the z-axis. But in Blender, our y-axis is facing backwards and our z-axis is facing upwards. However, in Fusion, while the x is still correct, our y-axis should be facing upwards and our z-axis should be facing forwards. So this is the issue that we need to correct that is coming from Blender. Similar to what we did last time, we will use a channel Boolean node. So let's go to the tools bar and drag a channel Boolean node. There are multiple ways we can go about loading a node. We can right click in the node editor, go to add tools, color and select the channel Boolean node, or we can go to effects, tools, color or select the channel Boolean from there. Lastly, if we cannot find our node in the tools bar, then press Shift space and it opens a search box. Here type the name of the node that you want to use and press add. So let's connect the position pass to it. Also, let's load this node into the viewer. In the inspector, we will first go to colors and switch them. The red remains red, to green turns to blue, and to blue turns to green. And now if we have a look, red is correct as it was before. Green, which is also our y-axis, is now correct and it's coming from the top. And blue, which is the z-axis, is almost correct except there is one problem. It should be coming from the foreground rather than the background. So now let's adjust the position data. Let's go to the auxiliary channels, enable extra channels, scroll down to X, Y and Z position and assign the correct colors. We are going to give this red, we are going to assign this blue and we are going to assign the Z green color. And now if we look over here, we can see that we have position data in our scene. And in the position, the x-axis is correct, the y-axis is correct and the z-axis is yet to be corrected. So how do we go about solving this issue now? Well, there is a powerful tool in Fusion called the custom tool. This tool allows us to create custom expressions and filters to modify and control various parameters of our nodes. So let's press Shift space and type custom and select the custom tool. And we can see that it's automatically connected, but if it isn't, then just click on the output of the channel Boolean nodes and drop it on top of the custom tool and it will connect. And in the custom tool, we can write various expressions and use these sliders to control or maybe even automate various parameters of our entire composition. The setup and intermediate tabs are where we write our expressions, but what we are concerned with is the channels tab over here. And over here we can see that the red channel has the R1 value assigned to it, the green has G1 value, and the blue has B1 value, and the alpha has A1 value. These are the values that we use when we are writing expressions that rely on color channels. But what we are particularly interested in is this blue channel over here. And here, we will flip the blue channel from negative to positive from backwards to forwards by just adding a minus sign before the B1. And now we can see in the viewer that the blue has flipped and this is correct. And we will apply the same adjustment for the position pass. Next, we go to auxiliary channel expressions. We'll scroll down to X, Y, Z positions. And if you remember, our X and Y was correct and the only problem was with the Z position. And right before PZ1, we will add a minus sign. And if we go to show color channel and we go to position Z, we can see that it has flipped, indicating we now have the correct information. And we can do this for normal passes as well as any other passes that use RGB coordinate data and channel data to generate 3D space. But how do we know that this is the correct information? And why do we even need to do that? Well, if we are creating or adding a 3D object in our scene, then we need the correct information, as incorrect position data can lead to misalignment. Let me show you how. So, let's set the custom tool aside for now, and we will even disconnect it. And what we are going to do is load an Alembic scene, which I have already copied here. And as you can see, it's a pretty huge scene. This is the entire scene that we are working on. So let's load it into Viewer 2. And as you can see, this is the same scene that we are working on. So let's just keep this in our mind for a second. And now we are going to load an image plane 3D. Now after the image plane 3D, we will add a displace 3D node to displace our object using various channels. The displace 3D uses channel data such as luma, RGB or position to displace an object, which in this case is our image plane 3D. So first let's go to the image plane 3D and change the subdivision value to 100. And we are going to feed our position data, our position pass, and drag the output and drop it on top of the displace 3D. And we can see that something is happening. Currently, the displace 3D is trying to use the luma channel to displace the object. But what we need to do is select the position data. Now we have this 3D object which is being displaced in the 3D viewport. But we can see that there is something wrong with this. So let's just connect our 3D scene to displace 3D and load it into the viewport. And now we can see that our displaced image is being displaced in the wrong axis. And that is why we need to have correct position data. But now if I connect the custom tool which has my corrected position data and connect this into the displacement node and use this to displace, we can see that now we have the correct displacement. But we can still see that it is not sitting well with our scene. So let's go back to the displace 3D node and in the mode, let's change from relative to absolute. Scale and bias are other ways we can use to control our displacement. But for now, we can see that this is correct and all of our displacement is sitting exactly where it is supposed to be on top of our 3D scene. Now, let's remove our 3D scene and let's move it over here since we are done with it. We can see that this is the correct displacement. All of them are in the correct position. And that is the reason why we need to correct our position data. And yes, currently it looks quite blank. So we can load a 3D camera and project our beauty pass using the 3D camera on top of this image plane 3D. But before that, I want to show you something. Over here we can see on our image plane that there are various stretched vertices. And that's because over here, there is no positional information. And hence, when we are displacing our image plane 3D, we get these stretch marks. And we can see this much clearer in the second example that I will show you later on. So now, we can go ahead and load our camera. So this is our camera that I exported from Blender as an Alembic. And now let's add a merge node and connect the camera to the merge node. Let's load it into the viewer and now we have a camera in our scene. So if we select our camera and in the inspector, we can choose which projection type we want. We can choose perspective or orthographic. We can select our angle of view, change our focal length or even the focal plane. And we can go over to the transform tab and position our camera anywhere we want. Now, please note that there are only 3 tabs over here. So now, the moment I connect the beauty pass to our camera to use it as a projector, we can see that 3 more tabs appear. These tabs contain the parameters to control our projection. Now, if we go to the projection tab and click on enable camera projection, we can see that it's not working. That's because currently our camera node is locked. So to unlock it, let's go over to the inspector and click on this unlock button. And now if we click on enable camera projection, we can see that the camera is now projecting our beauty image onto the image plane 3D. So this is one way. Another way is to connect our beauty pass directly to the image plane, and it still works. But the only purpose of using this displacement is to be able to place a 3D object or 2D cards accurately in our 3D space. So now let's import an object, a terracotta Bankura elephant, into our scene. So this is our elephant, a Bankura elephant, and we're going to place this on top of our picnic table. So let's load a new merge node and connect this merge node to the new one. Also, connect the elephant transform node to the merge node. So this is our transform node. But first, let's load the merge node into the scene. And now in the transform node, we can use the picker to place our Bankura elephant anywhere in the scene. But if I try to place the elephant somewhere over here, we are not going to be able to place our object in an empty scene. As you can see in the dialog box, the position X, Y, Z gives a 0 value. The only way we can place this elephant in the scene is by using the displace image plane 3D. So when we place the elephant over here, we can see that now the X, Y, Z coordinates are available. And this is how we place a 3D object in a scene using the position pass. This is the power of the position pass. And this is the reason why we need to have correct position data in our composition. Now let's see what it looks like when we render it out. Once we have placed the object in the scene, we can remove this since we don't require it anymore. Now let's go to the tools bar and load the renderer 3D. Now connect the merge 3D node to the render 3D, and now we'll connect the render 3D to the beauty pass using a merge node. In the render 3D node, we will change the camera to the camera that we have in our scene. Then we will change the render type to hardware render. And in the image tab, we will change our resolution to the resolution of the beauty pass, which is 3840 by 2160. And now let's just load this into the scene, and we can see that it is placed exactly where we had positioned it. And if we connect that, we can see that everything is in its correct place. Currently, our elephant doesn't look like that it is a part of our scene. So let's add some lights to our scene. So let's add a direction light and an ambient light. So press shift space and type direction light. And let's load that into the scene. Type ambient light and let's load that into the scene as well. A directional light is a light with clear direction but without a clear source or distance, similar to the sunlight. An ambient light is a directionless light that globally illuminates the scene, similar to the sky. So we are going to add a merge node over here, and we're going to connect the direction light first. Let's switch on the shadows as well, and currently the direction light is coming from the front. We need it to come from this angle over here. So let's correct that. We go to the direction light transform settings, and we are going to rotate it in the y-axis sort of like this. And we will also rotate it in the x-axis sort of like this. And we need to match the shadow casted by the direction light to the shadow that already exists in our image. Okay, now this is correct. And our shadow looks too boxy and pixelated. So to correct that, we go to controls and we first increase the intensity of the direction light to 1.5. And then we will go to shadows, and here we will increase the shadow map size. Remember, when you increase the shadow map size, it will eat into your processing power. So be mindful of that. Now we have a much smoother shadow. And as you can see here in this image, we can see that the light is creating the highlights and the shadows. And the shadows are honoring the curvature of the objects. Now, we go to the direction light, and in controls, we will change the color to a slight warm color to introduce a very slight warmth into our scene. Next, we will connect the ambient light And in the ambient light, we are going to change the color to a very light blue. Now this is what a scene looks like. Now we will load the renderer, and in the renderer we will go to controls, and in the lighting we will enable lighting and shadows. Now we can disconnect our displace image plane from the scene. Now let's load this, and we can see that our elephant is now lit, but it still doesn't feel like a part of the scene. So we now need to add shadows to the scene. Just for now, let's connect our displace image plane back into the scene. Now, unlike many 3D renderers, Fusion does not have a shadow catcher feature. So we have to somehow find a way to separate the shadow from the elephant. And for that, we will first duplicate the render 3D node and connect the merge 3D node to that one as well. Now this render 3D node will only show the elephant, and this one will only show the shadow. So how do we separate the shadow from the elephant? For that, we will use the override 3D node. Using this node, we can, let's say we do not want a certain object to be visible. So we can select do unseen by camera, and the moment we load this, we can't see anything. But to make sure only the elephant is visible, we can scroll down over to the exclusions, and we can select limit by object ID. And when we enable it, it will ask us what object ID do we want to use. By default, it is assigned 1. So let's go over to our image plane 3D, and over here, let's go to the object ID panel. And here we can see that it has been assigned a value of 153. Now let's go back to the override 3D and change the object ID to 153. And now our image plane disappears and only the elephant remains. Now let's repeat the same process for the ground plane as well. For that, we will go to our elephant objects, and one thing you need to know is that there are two objects in this scene. There are these bells, and then there is the elephant, and they both merge to form one object. Select cylinder 310, let's go to its object ID, and we can see that it has been assigned the object ID 1, and the elephant has been assigned the object ID 5. So let's change the cylinder object ID to 5 as well. Now let's copy and paste the override 3D just before the first render 3D node. Press shift space and hold over the wire to connect it. Now go to exclusions object ID and change it to 5. Now the elephant is gone and only the shadow plane remains. But we cannot use this image plane 3D as our shadow catcher, because as you can see that there are all these weird artifacts happening. That could be because it has a very low subdivision, so we can change the subdivision to 500. But the other problem still remains, and that is that it is casting shadows of the stretch object as well. And that is why this image plane is unusable as a shadow catcher. So first let's remove this, and now let's load this into the viewer, and let's make some space over here. And now we are going to load a merge node in between these two, and we are going to connect a image plane 3D to this merge 3D node. And this image plane 3D is going to be our shadow catcher. Now let's go to image plane, go to transform, and in the rotation we are going to rotate it -90 in the x-axis. And then let's go to scale and uncheck uniform scale. And then let's scale it in the x and the y-axis. And we can see that it is sitting correctly in place. But if we need it, we can use the translation to place it anywhere in the scene. So let's have a look. Now this is what our shadow catcher looks like. But now how do we remove the image plane? Well, it's simple. Let's go to the merge node, and then let's go to apply mode. And instead of normal, we will select multiply. But we can still see our image plane. Well, this can also be solved. After render 3D, press shift space and type brightness contrast. And in the brightness contrast, we will increase the gain slightly until the shadow of the image plane disappears. But we can now see that our shadows are not honoring the contours of the orange. To solve that, first, let's connect the displace image plane into our scene. Next, we will load a shape 3D node, and we will change the shape from plane to a sphere. Now let's reduce the size since it's a bit too big. Now let's connect it to the merge node, and now we can use the transform picker, and let's place it as close to the orange as we can. and then manually set it into position. And then we can scale it up to roughly the size of the orange. Now this is one way how we can go about doing this. The other way is to import low poly objects of the same and use those as a shadow catcher. And now let's duplicate the Shape 3D node and drag it back on top of the second orange. Now we can disconnect our Displaced 3D seed and let's have a look at the renderer. And over here we can see that our spheres are catching the shadow and they are not affected by this override node. But they should be affected by this one and they're not. So let's tackle that. The original image plane had an object ID of 153. So now let's go to our Shape 3D and change the object ID of this sphere to 153. And now we will do the same for the other sphere as well. But now we can see that they are casting shadows, which we do not want. So let's go back to the Shape 3D and in Controls, let's go down to Lighting and switch off Shadow Caster. And now we can see that it does not cast any shadows. And we are going to do the same for the other sphere as well. Now we can see that they are not casting any shadows. But if we look over here, we can see that they are still being affected by light. And we don't want them to be affected by any light whatsoever. So let's select the Shape 3D. Let's go to Material. And in the Transmission panel, we will uncheck Receive Lighting. So now we will be receiving no lighting, but we will be receiving the shadows. Now let's do the same for the other sphere. And we can repeat the same process with the image plane. Now they will receive shadows but no lighting. Now let's go back to our scene and we can see that we do not need the brightness contrast node anymore. So we can delete it. And this is what our shadow looks like. Now let's connect the elephant with the rest of the scene using a merge node. And now let's load the merge node into the viewer. And we can see that we have an elephant which is casting shadows, which is being honored by the curvature of the oranges. So let's work a little bit more on the shadows. So after Render 3D node, we will add a color corrector node. Let's tint the shadows to blue so that the color of the shadows matches the color of the rest of the shadows in the scene. And we can adjust the lift to darken our shadows however much we need. Now this looks okay. The best part is that if I move the elephant anywhere in the scene, we can see that now our shadows are honoring the light and the curvature of the objects in the scene. So this is how we can go about creating lights and shadows for 3D elements in Fusion. So this is our composition. And if you look down, I have added some contact shadows. And I'll run you through how I went about creating it. So I used multiple volume mask nodes and then merged them all together using a multi-merge node. For the volume mask node, I was using the corrected position data and then I combined them together under the feet of the elephant. These are the settings of our volume mask node. First, we are using the sphere shape. Then, using the translation, I have moved it under the feet of the elephant. Finally, I scaled it down and gave it a very soft edge. Now in the brightness contrast node, I have reduced the gain and the lift to create these very dark shadows as well as retain the blue tint. Then I have merged them all together and this is our final scene. Now this was the image plane displacement technique. Now the main issue that I found with this technique was 1. The amount of subdivision we need to use to get a clean scene, and 2. The stretch vertices. Now there is another technique that we can use, one that Nuke is quite famous for, which is the point cloud technique. So here we have a beauty pass and the corrected position pass. And the next thing we are going to do is add a particle image emitter node. So press shift space and type image and we will select the P image emitter. Now load it into the scene. And currently we will not be able to see anything because to view particles we need to connect them to a particle render node. So let's drag a particle render node and connect a P image emitter to it. And the moment we load the P render node into the viewer, we are now able to see our particles. Now we can see our picnic table image. And this image is made up of tiny particles. To be better able to see them, let's reduce their amount. And in the P image emitter, we will decrease the density. But if I try to decrease the density, I can only do it non-uniformly. But what if I want to decrease them together? Then to achieve that, I will use an expression. And in the Y density value box, type the equal to sign and it opens an expression box. Then drag and drop the pick whip on top of the X density. And now we have connected the X and Y together. And now if we try to reduce the X density, we can see all the individual particles. Let's go back to the default. Now to displace our particles in 3D space, we will use the corrected positional data stored inside a custom tool, and we will connect the custom tool to the pCustom node. The pCustom node is very similar to the custom tool. Here too we can write custom expressions and use these sliders to control the behavior of our particles. And now we will connect the custom tool to the pCustom node. And in the custom node, we will go to the particles tab, and here we will write our expressions. Now I will copy and paste these expressions, and you can see the expressions on the screen, so you can pause the video and copy the expressions somewhere for later use. Now we can see our particles are displaced in the 3D space. So now let's load a shape 3D node. And in the shape 3D node, let's change the shape from plane to sphere. And let's reduce its size. Now if we go to the transform tab, we can use the translation picker and place it anywhere on the particles. We can place it here, we can place it here, and if you remember, if we try to place it over here, we will not be able to do so because there is no position data behind these apples. So as you can see, this is much cleaner than the image plane displacement. And if we want, we can reduce the amount of particles visible in the scene, and it will still maintain all the details. For now, I think this is enough to get you to understand the power of position pass in deep pixel compositing. And I hope you understand the importance of having a correct position pass data. Now, as far as the particle displacement and the image displacement techniques are concerned, they are both correct. They both do the same thing. I just think that the particle displacement gives us a cleaner result, while there are way too many stretch vertices in the image plane displacement. And to even get a relatively clean scene, we need to increase the subdivision to a huge number. But as I said, in the end, they both do the same thing. And you may choose whichever technique that works for you. And that's all for today. Please don't forget to like, subscribe and ring that bell icon. Until next time, see you.